Hello, my name is Heisenberg and welcome to Solution Basics. In this experiment we will create a homogeneous mixture which will contain sodium acetate as our solute and water as our solvent. Now my business partner Gus will show you the different types of solutions.
Now we will be making an unsaturated solution.
I am the one who pours.
This is an unsaturated solution because, as you can see, after mixing it thoroughly, there's no solute still undissolved. Now we will be making a saturated solution.
This is a saturated solution because after thoroughly mixing the solution, there are still sodium acetate particles at the bottom.
The next step in the process is to create a supersaturated solution by placing the saturated solution in a hot water bath. Here is the saturated solution, which we will put into the heated water bath and put to boil. For 2 minutes.
Now that the saturated solution containing excess sodium acetate has been heated for 2 minutes and then cooled down, it is now a supersaturated solution because more solute is dissolved in the solution at room temperature than a saturated solution would be able to dissolve. Now, we are about to add what is known as a seed crystal of sodium acetate. The seed crystal of sodium acetate being added to this supersaturated solution will result in the rapid crystallization of the solution as you are currently seeing, as it should by the definition of a supersaturated solution we gave earlier in this video. But remember,
this is not meth.
Thanks, Mr. White, for clarifying that for us.
Better call Saul for the factors that affect solubility in the solubility curve.
Hello, Saul Goodman here, and I'm here to teach you about factors that affect solubility in the solubility curve. First, we will explore the factors that affect solubility. First up are intermolecular forces. Solutes and solvents with similar intermolecular forces are more likely to dissolve in one another. As you saw in our sodium acetate experiment, the polar sodium acetate dissolved in the water, another polar substance, and nonpolar substances would do a similar thing. Next up is pressure. A good example for how pressure affects solubility is a can of soda, as I have right here. The pressure when in a closed can of soda is greater than the pressure on the outside. So when the soda is open and the pressure on the outside, since it is less than the pressure on the inside, solubility of gas particles decrease, and that is why the gas particles rise when the can is open. Next up is temperature. For solids and liquids, temperature, when it is increases solubility. Once again, as you saw in our sodium acetate experiment earlier, when we increased the temperature of the saturated solution of sodium acetate, more sodium acetate was actually able to dissolve. Similar would be done for liquids. For gases, the opposite is. So, when temperature increases, gas solubility decreases. Once again, using soda as an example, if you leave a carbonated soda out for hours, it becomes flat because the solubility of the gas particles decrease and leave the cup of soda. Now I will be teaching you about a solubility curve. This is what a solubility curve looks like. On the x-axis is temperature in degrees Celsius, and on the right is the solubility in grams per 100 centimeters cubed or 100 milliliters of water. I will be using sodium nitrate to explain what it means. So, let's say a solution used with sodium nitrate of 100 milliliters is at 15 degrees Celsius. Based on the graph, right here, that would mean just about 80 grams of sodium nitrate can dissolve in the 100 milliliters of solution if it is saturated. If it is unsaturated, it would be below the line because less than what a saturated solution would need would be in the solution. And if conditions are altered, so more sodium nitrate can be dissolved in the 100 milliliters like we did earlier with sodium acetate, it would be above the graph, a supersaturated solution where any rapid change could cause crystallization. So this is what a solubility graph is. And remember, if you ever need to know about factors that affect solubility or a solubility curve, better call Sol.
Now we are going to quickly review what you have learned about solutions from this video. First, the definition of a solution is a homogeneous mixture, and an aqueous solution is a solution where water is the solvent. This brings us back to what solvents and solutes are. A solute is the substance that is dissolved, and the solvent is the substance that does the dissolving. Next, let's review the three different types of solutions we went through. An unsaturated solution is a solution where more solutes can still be dissolved. A saturated solution is a solution in equilibrium, which means it must have undissolved solute on the bottom. The last type of solution we looked at was supersaturated, which is an unstable solution where conditions have been altered so that you are able to dissolve more solute than in a saturated solution. And in this type of solution, any quick change will result in rapid crystallization. Next, we will look back on the factors that affect solubility. Substances with similar intermolecular forces are more likely to dissolve in one another. Polar and polar, or nonpolar and nonpolar. You can remember this by the saying, like dissolves like. Next, in pressure, which only affects gases, a decrease in pressure decreases the solubility of a gas, as seen in a can of soda. Lastly, temperature affects solubility differently for solids and liquids than it does for gas. For solids and liquids, a temperature increase increases solubility, but for gases, a temperature increase decreases solubility. Thank you for watching our video, and we hope you enjoyed it as much as we had recording it.